Okay, so far, can you quickly summarize what all things we have discussed in data in statistics? We discussed about mean median mode, correct? We discussed
Yes, sir.
about
Yes. Yeah.
standard deviation,
Yes, sir.
right? We
Yes.
discussed about variance. We
Yeah.
discussed about
Yeah.
what is the difference between variance and standard deviation, when to use. We discussed about accuracy and what is the other word? Precision,
Precision. Oh,
right? Accuracy
Yeah.
deals with your average,
Accurate.
right? And precision deals with your standard deviation, where your variability has to be less. We discussed positive, negative, skewed graph as well, right? Okay. We
Yes.
discussed about scatter plot, box plot, and histogram. These are the three important plots from data analytics perspective.
yes.
Okay. Okay. We'll do a few more graphs when we get into Power BI later towards the end. Okay.
Okay, sir.
Okay. So now, so of course, right, we know all these things, but to perform all this, first we need to get the data. We need to read the data, right? We need to be able to read the data and process, correct? So how do we do that? Okay. How do you read the data? Okay. So when for that purpose, we have to discuss about three or at least two. We'll discuss about three, but two of them are really very important. Okay, for reading any data, whether we are doing descriptive statistics or when we do machine learning later. One is your Numpy, and then second one is SciPy, and third one is Pandas. Okay, they are advanced data structure. Okay, data structure. We discussed about five basic, plus then we discussed about four data structures, right? What are those four data structure that we discussed? And those were one dimensional. Do you remember that? List, tuple, dictionaries, and sets. So what
That's
we are
yeah.
doing now is an extension of list, tuple, dictionaries, and set. Okay, those were one dimensional, and now we are going to talk about two dimensional and multi-dimensional basically. Okay, so first thing is NumPy, and I don't think you need to import, but if you don't see it, please import it. Okay, so we say NumPy, and we will give an alias. So we'll say NumPy as NP. Now, NumPy is a data structure to handle your matrices. Okay, matrices are foundation for machine learning. Okay, since we are doing we will be doing from programming perspective. Okay, we will not get too much into the mathematics part of data science, but you need to know that matrices are foundation. So if you want to understand really about the real machine learning algorithms, and if you want to do more advanced research, you should go back to your subjects and read about matrices. Okay, if you want to read a video, audio, pictures, okay, the data is converted into matrices actually. Okay, you talk about say PCA, okay, principal component analysis, and we'll do that when we do machine learning. Okay, you need to convert the data into matrices. Okay, so matrices, eigenvalues, these are kind of foundation. Okay, we will not get into too much into that because our focus is more from programming perspective. We'll understand the concept and we will learn to implement it. Okay, but if you want to dig deeper, okay, if you want to get more deeper into how a particular algorithm is designed, okay, you should get into um, matrices. Okay. Okay. So how do you define, how do you create a matrices using NumPy? Okay. So let's say, so here, let's say we use function called range. So do you remember what range function does? We use it using for loop. What does range do?
From 0 to n minus 1, sir.
Correct. So it's going to generate values Here, I have not given the increment value. I have not given the starting value. So it'll start from 0, increment by 1, and goes up to whatever value I give. So if I give 16, it is going to generate values from 0 to 15, right?
Yes, sir.
So I'm going to say x equal to range of 16. So x will have values 0 to 15. Now I can reshape it. Okay, reshape is again a property of NumPy. So this is a function reshape which will convert or put this in a, see, range will generate a series, single dimensional values. I want to reshape into 2-dimensional. So I can say x equal to np dot reshape. Okay, and here you say that which value you want to reshape. I want to reshape x into what format? Okay, into, you have to give tuple here. You can say 4 comma 4, you can say 8 comma 2, you can say 2 comma 8. I cannot say 4 comma 5. Okay, if I say 4 comma 5, what happens? And let me print x here. Okay, so you have size 16 and you want to reshape it into 4 comma 5, 20. 4 comma 5 needs 20 values. So you cannot reshape 16 values into 20 values, right? Similarly, I cannot say here 4 into 2. Okay, because 4 into 2 also, here it needs only 8, but you're giving 16. Okay, it doesn't know what to do with that extra number. So you have to reshape exactly using, you have to exactly use all the numbers that you provide. Okay, so I can only say 4 comma 4, or I can say 8 comma 2, right? So see, 4 comma 4, it has created. So what do you notice here? This is like matrix, isn't it? How many rows and how many columns it has?
4, 4.
Okay, so yes, so this
Uh,
is what you're
four,
passing. So
four
this is your number of rows and this is your number of columns. So if I say
columns.
8 here and I say 2 here, then I'm saying 8 rows and
2 columns.
2
2
columns.
columns. So see, you got 8 rows
Okay.
here, 1 row, 2, second, third, 8th row, and only 2 columns. Okay, and values are always displayed as row, right? So values are getting displayed as rows, 0, 1, then 2, 3, then 4, 5. Okay, so you can reshape it into any format. Okay, so NumPy is a 2-dimensional format. Okay, now you can even create dummy matrices. So I want to create matrices with only 1 values. Okay, with all 1, 1, 1, 1, 1. So I'll say here x2 equal to, okay, np dot ones. So when you say ones, okay, it is going to generate all ones. Fine, but it needs to know what is the size. Okay, which size of matrix you want to create. So I'll say 3 comma 3. When I say 3 comma 3, it will generate me 3 by 3, right? So it generated 3 by 3 and all the values are 1, 1, 1, 1, 1. Make sense? Okay. You can have zeros. Okay. But you can't have twos. You have zeros. But let's say if you want to create matrices with all 9, 9, 9, 9, all 11, 11, 11. So you have something called as full. X3 equal to np dot full. And then you mention here first, okay, what size? Okay, so if I say 4 comma 4, it's going to generate 4 by 4 matrix. And matrix should have which value? I'll say 11. So now when you run x3, okay, you will get all 11, 11, 11. So see here, if you notice here, each of these is a list. Yes. So each row is a list and the matrices becomes list of a list. Each row is a list, and then this is all is another big list. Okay, so you can even convert a list of list into numpy or matrix. So if I want to create my own generic value, so I'll say x4 equal to list and each row. So tell me how many rows this matrix will generate? How many rows and how many columns this matrix will generate x4?
Four rows and four columns.
4 rows is correct, but of course you can't say column because you don't know
Okay.
which value. Yes. So if you want to convert it, this is a simple list. You want to convert into numpy or array, we have to say array. NP of array, you say x4. And now if you print x4, you will get matrix. But here, yes, we have to give data. So let's say in first row, I want 1, 2, 1. And then I want 1, 1, 1. Here I want 2, 2, 2. Here I want 3, 1, 1. Okay. Now when I run it, so you see 1, 2, 1, 1, 1. So we created 4 rows and 3 columns. So this is how you can generate your own data. You don't have to depend upon, functions like range to generate your value. Okay. Okay. Next comes indexing. How do you read the content? I want to read subset of this matrix. I want to read a part of it, right? So we do indexing. We did indexing for everything, right? For list, tuple, dictionaries, set, list. We did indexing. What is indexing? What we try to do?
Sir,
Read a part of it, correct? So when we
sir,
were, sorry, Abhi.
sir, once could you repeat the X4 part? NP.array.
X4. Okay. So see here. Okay. For now, for a moment, you forget this. Okay. What do you get? What is X4? What is X4?
List.
List. Yes. X4 is a list. Okay. And this is what we have discussed before. So it is a list. Okay. It is a list of list. Okay. It's a list. And
Yes,
each
sir.
member is also a list.
Yes, sir.
Right? So if you have a list where each member is also a list, you can convert this into your array or numpy object or your matrix. How? By using function called as np.array. Okay, so array function of numpy actually will convert your list into a matrix. So I'm simply saying np.array of x4. So this list goes as input to array. And now when you run it here, you see it has got converted into numpy dot nd array, n-dimensional array. That's what it says, 2-dimensional array. N value here is 2-dimensional. So it says 2-dimensional array.
Yes,
Makes
sir.
sense now?
Yes, sir.
Okay. Then you have, okay, so we're talking about indexing, right? So what is indexing? Indexing is reading value, correct? So I don't want to read entire. If you want to read entire, obviously you will say print, right? I don't want entire value. I want a part of this. I want part of this this index or this matrix. Okay. So when you were doing 1-dimensional, we had starting value and ending value, right? But now what happens? Okay. Now we are talking about 2-dimensional values. So you have starting and ending value for row as well as starting and ending value for columns. Correct? So you have to have starting and ending value for row. Which row you want? I want first 2, third row. Which column you want? Second to third column. So you are asking for both row and column, right? So you need to
Like
give
2D array.
two dimensional, yes. So let's say x4 only. Let's say I want to print this 1, 1 and 2, 2. Okay. I want to print 1, 1 and 2, 2. Okay. So let's see how we will do it. Print x4. Okay. Indexing, which bracket do we use?
Square brackets.
Square bracket, yes.
Square.
Yes. So we say x4 of square. Now you see. Okay, I want this 1, 1. So what is the row number here?
2, 1.
Which row is this?
2, 2.
Second
2, 2.
row, but number is 1, right? Counting starts from 0, right? So it is 1, correct? Colon. Okay. Till which row you want to go?
Till 3.
You want to
Three,
go up to 3 row, right?
3, 2.
Which is 2, right? You want to go to index 2. So if you
Yes,
want to
sir.
go to 2, you have to say 3, isn't it?
Yes, sir.
One more, right? So this is how you will pick your rows. Now, column. Tell me what will be the column value here. So comma. The way you write row, comma, column. So column here is first
Second.
column, right? I mean,
Yes,
first
sir. 0.
index. And then up to the end also you can say, correct? So 1 colon, and if you
2.
want to go up to end, you can leave it blank, correct? Left side, if you leave it blank, it starts from 0. Right side, if you leave it blank, it means go up to the end. We are going up to the end, last column. We are going up to last column. So you
Yes,
can
sir.
say here colon, or you can say 3 here, right? So 0, 1, 2. We want up to 2, so we have to say 3, right? So you can say 1, 3, 1, 3, right? So you get 1, 1, 2, 2. Or you can leave it blank also, because 3 is anyway going up to the last. You get same answer. So this is how you can do what? Indexing. Right? Okay. Now you can perform addition, subtraction, multiplication, division of matrices. Okay. So this is x4 and we will take x5 here, let's say. And okay, this whole thing we will convert into array, right? So I can say something like this. So I'm using same values for x4 also, same value for x5 also. So print x4 plus x5. Okay, what do you get? You get 1 plus 1, 2 plus 2, 1 plus 1, right? So 2, 4, 2, 2, 2, 2, 4, 4, 4, 6, 2, 2, isn't it? So you're adding same matrices, correct? You can do minus also of two matrices. So far easy, right? Yes
Yeah.
or no?
Yes.
And when you multiply, obviously, you'll get 0, 0, 0, right? 1 minus
0.
1, 2 minus 2, 3 minus 3, correct? Okay. So you get 0. You can do division. You can do multiplication also. How to do multiplication? You will say print x4 into x5. And when you say x4 into x5, okay, you get this. 1 into 1, 2 into 2, 1 into 1, 1, 4, 1. 1 into 1, 1 into 1, 1 into 1. 2 into 2, 2 into 2, 2 into 2. 3 into 3, 1 into 1, 1 into 1. Correct? So this is how you can do matrix multiplication. You can do matrix division. What will be the output of division? Huh? When you divide a number with the same number, what do you get, man? Or
1,
women?
sir.
1,
1.
right? So why are you thinking so much? Okay, looks like you are Okay, fine. No problem. My voice is breaking, is it?
No, sir, it's okay.
Okay. Melissa, you want to check your internet?
It's uh, it's perfect, I guess.
Okay. Can you hear me now?
Hello, am I audible?
Yes, yes, I can hear you clearly.
Am I audible?
I can hear you. I think your audio has some problem, Mona Lisa, I guess.
Okay.
Can you
Okay.
hear me?
Okay.
Hello. Abhi, you can hear me, right?
Right now.
Yes, sir, it's clear for me.
Okay. So I think your
Okay.
speaker had problem. We could hear you, but you could not hear us.
Okay. Actually, I've connected Bluetooth, but I don't know where we went wrong. I guess
Okay.
some network issue from my end, but
No, no,
it's
I don't think
fine
network
now.
issue. I think it's Bluetooth speaker only. Because I could hear you.
Okay, it's that.
I could hear you.
Okay, okay.
Hmm. Okay.
All right. Now it's perfect, so we can continue.
Yes. Okay. So I was saying when you divide same number, with same number, you get 1, 1, 1, right? So this is how you perform division. But is this how you perform multiplication in matrix? No. Okay. So you also have a function, okay? Just like set, we could do union using symbol and also using function. Same way, matrix also you have function. So you have function like np dot add. Okay, you can say x4 comma x5. So you have np dot add, you have np okay, subtract. Okay, then you have multiply, and you have divide. Okay, let me take a sip of water. Okay, so this is how you have multiply and divide, and you get same answer. Okay, you can do using symbol or you can use function. Okay, so this is not actually how you perform. Okay, you can even perform, let's say here. You see this? See here, you got 1 point because this will give you, with decimal value, float value. Output will be float
Modular, sir.
values. So 1 point you got. But when you do double slash, it will give you integer output, right? So that's why you see you got only 1. There is no point here. Okay. The next thing is you can also perform say square root. Okay, NP has, see, NumPy also has all the functions that you have in Excel. Okay, so you can say NumPy dot square root. Okay, NumPy dot average, NumPy dot sum, right? Everything that you have in Excel you can do in NumPy. So here I want to find square root, let's say.
Sir, mean also we have, sir.
Let's see. You have it right?
Yeah.
So mean is same as average, isn't it? So you have mean. you do not have mode. Okay, you don't have mode. Okay, you
Median
have
system.
median but. Okay, so square root of x4, and let's print it. So see, it gave you square root of the matrix here. So each number got square root. Now what happens if I find, we discussed about average, mean, right? So if I do mean here, what do you get? What do you think will be the output? Okay, so you have 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 18. 18 by how many values you have? 12.
No, 12.
18 by
12.
12. 1.5. That's why I see you got 1.5 here. Okay. You want to find the shape. Okay. Let's say, somebody has entered the matrix and you don't know, the size of the matrix. So you can say numpy dot shape. Okay. Print shape of the matrix. Okay. So you will say np dot shape. Okay. And you say, okay, sorry here. Yeah. X4. So shape is 4 rows and 3 columns. Correct? Okay. Now coming to matrix multiplication, this is not matrix multiplication. Do you remember how matrix multiplication was done?
Yes. Like it's like row to column.
Row to column, yes. So we have function called as matmul, matrix multiplication.
Yeah.
Okay. Matmul function or @ sign will give you matrix multiplication. But one more thing you have to remember is there's some condition. You cannot multiply any matrix with any matrix, correct? You cannot multiply any matrix with any matrix. So when you are performing, you're saying matrix 1 into matrix 2. So when you say, let's say this is your A matrix. So when you say A into B, right? And if A is of size M into N and B is of size X into Y, okay? If it is M into M and X into Y, then what is the condition here? First condition is N and X should be equal. Okay, so the left side. So see, in when you are dealing with numbers, right? Integer or float, matrix will the order of multiplication doesn't matter, right? Whether you do 3 into 5 or you do 5 into 3, it's going to be same value, correct? 3 into 5 is also 15, 5 into 3 is also 15. So it doesn't matter. But when you do matrix multiplication, matmul, actual matrix multiplication, not multiply, the matrix multiplication, okay, A into B is not same as B into A. Okay. So A into B, it's going to be your N and X should be equal. Only then matrix multiplication is possible. And the output matrix C will be of size M into Y. M rows and Y columns. Outer will remain. Inner will, okay. We'll just check the values only for condition check. Okay. So we have X4 and X5. What is the size of X4 and X5? We just did. No, what is the size of X4 and X5? X4 is 4 rows, 3 columns. And this is also 4 rows and 3 columns. So 3 and 4 are not equal. So here matrix multiplication is not possible. Okay. Matrix multiplication itself is not possible. So if I try to do matrix multiplication of print x4 at the rate x5. Okay. One operand, operand one has mismatched its core dimension.
Sir, you can't see your writing.
Oh, yeah. Sorry. I moved away from print. Yeah, now you should be able to see. So this is how you perform matrix multiplication. Okay. Matrix multiplication you can perform using at the rate sign, or you can perform using np dot mat mul. Okay.
Sir, at the rate sign means x4 into x5 or x4 power x5.
At the rate is matrix multiplication. Matrix multiplication.
Okay, x4
Goes
into
into
x5.
column. Yes, no. Okay. So here your x, the number of columns of x and number of rows of x5 should be same. Only then you can perform matrix multiplication. Otherwise, you cannot perform matrix multiplication. Okay. So that's why you got this error. Okay. So now what I'll do is I will create x6. X6. So it has 4 rows and 3 columns. So here we'll make 3 rows. So rows and columns should match, right? So I'll make okay. And I need to give how many columns we need to add? Columns doesn't matter. Okay.
Or as four, 3 columns and 4 rows. Sir.
No, column doesn't matter. What I said only equal the the column of first matrix and row of second matrix should be equal. That's the only condition. Okay. Nothing else matters. So number of columns can be anything. You can give even 1 column also. 5, 6, 4. So what happens? Okay, we'll give F6 here. So let's go back to paint. Okay. Now we are on paint here. So X6, if you take, X6 is 4 into 3, and this is 3 into 1. This is equal. Output will be 4 rows and 1 column. So output will be 1, 2, 3, 4 values. Okay. So when I go back here now, okay, I'm going to the program, and when you run it, you see 4 rows and 1 column. This is from @ sign. This is from your matmer. Yes. Total silence. Say yes, no.
Yes, sir. Understood.
Yes. Okay. Okay. So I think this is also clear. Now, let's do an example here. Okay. Where this is used is to solve your algebra problems. Okay. You have this here, right? When it says that father is 5 times age of his son, 3 years back he was 6 times, what is the age now? Such problems you can solve using matrices. Okay. So while doing so, we'll come to know about how to perform inverse. Okay. What is identity? What is inverse? We will see that. So let's take an example here. Let me do some. What I'll do is I will take, let me take an online problem. Okay. So I'm going to perform search here. Linear algebra problems. We'll take simple problem. So what does it say? Hmm. Okay. So this one, this document I recommend it. Okay. Download this document. This will revise your matrices stuff. But okay, let's take some example. Okay. Let me go back to program here. Let's take an example. Okay. So let me frame it. Okay. And we'll go with back tracking. Let's say x equal to 5 and y equal to 4. Okay. Now 3x minus 2y is what? 15 minus 8. 7, correct? And 2x plus 5y equal to, okay, 3 into 15 plus 35, 40, 50. Okay. So we know the answer is x equal to 5 and y equal to 4. Let's solve it using this equation. Now you see here. So you have equation as 3x minus 2y equal to 7 and 3x plus 5y equal to 50. Okay. This you can put it in a form of a into b equal to c. So a is the value, b is the question x and y, and c is the output answer. A is the value. So A will be like, A will be, okay. How many rows, how many columns? 2 rows, 2 columns.
Yeah.
First row is 3 comma minus 2.
Yeah.
And second row is 3 comma 5.
3, yeah.
Okay. Now you get B
B.
is x comma y. So B we need to figure out. Now when you say A into B equal to C, then and B is what we need to figure out. Okay. B is xy. First value is x, second value is y. So B will be equal to A inverse. We say A inverse. Okay, because when you take matrix on the right side, multiplication becomes division. Yes. So multiplication becomes division. So you know, by one by matrix is inverse, matrix inverse. So I'm going to say A inverse into B. Okay. What is C? C has 2 rows and 1 column only. So it has 2 rows, right? First row, second row. Column, it has only 1, 7 and 50. Second value is 50. First value is 7. So now I have to say A inverse mat mul C. Okay. So how to find A inverse? Now you see, before you find inverse, we need to figure out the determinant value. Okay, determinant is one single number that can represent all the values of a matrix. Determinant is one single value that can represent all the values of a matrix. So if determinant is 0, we cannot find inverse. Can you find inverse of 0? No.
No.
Okay, so we need to figure out determinant. Find determinant, and if it's non-zero, only then perform inverse. Inverse. Okay. So what I'll do, I will create variable called det or det of A, let's say, equal to np dot, you have linear algebra in np. Okay, so we will use linear algebra dot determinant det of A. So this will give you determinant of A. Now, if this is not 0, if this is not equal to 0, then you go inside. We need to figure out inverse of A. Inverse of A again using linear algebra. np dot linear algebra dot inv. Inv of what? A. Okay, so inverse A. Now we need to find the solution. Solution is inverse A at the rate, okay, your C. Print solution. What did I put here? S capital. Okay, and then if you come here, print solution is not possible. You run it. Oops, you got different answer, is it? Is it correct first? Let's see. Oh, we did not convert into metrics, right? We need to convert this into metrics, right? Np dot array. Okay. It says 6.4 and 6.14. Let's see if this answer is correct or not. Maybe this answer is also correct. So we say 3 minus 2. 3 minus 2 equal to 7. 3,550. 3,550. Now you're giving answer as 6.43.
Sir,
And yeah,
so if we give you, let us take the second equation, 3x plus 5y. 3 5s are 15 plus 5 4s are 20. How it will get 50, sir?
oh, 20 plus 15, 45, correct?
Yeah.
I counted 7 into, see. But let's see if this is correct or not. Okay. So what it says is, okay, this into 3 plus this into 2. 7.01, see? 7. And this should be 50. So this into 3 plus this into 5. 49.99. Yes. So this is correct, right? We got it right. But you are right, okay? I miscalculated. This is 45. If you do 45, then you should get 5 and 4. No, we changed here, but not here. Wait. 5 into 3, 15. 15 minus 8. 15 minus 8. This is correct. Now 5 into 3, 15. 15 plus 20 is 35, not even 45.
35.
Now you get 5 and 4, right? Yes. So this is how you can solve problem using Numpy, okay? So we just solved a linear algebra problem. Okay, so why do we use matrix? Why do we use Numpy? Numpy is used to convert into matrix format. Okay. The next topic, okay, we'll do is called SciPy. Okay. The reason I told you to download that file because it has optimization problem also. So today I'll just start with the SciPy basic. Tomorrow we will talk about what is optimization. Optimization, see, if you talk about mathematical problems, you will come across 3 main problems. Okay. So first type of problem is called as prediction problem. Okay, what is prediction problem? The one we are going to discuss in machine learning. Okay, what will happen? Okay, it's about what will happen. Okay, the next type of problem is called optimization problem. How to best utilize your resources. Optimization problem is how to best utilize your resources. So let's say as a business, okay, we want to have what? Maximum profit and minimum cost. But is it possible to make zero cost? Is it possible to have zero cost in a business?
No, sir.
No, it is not possible to have zero cost in the business, because business will always consume some cost, right? You cannot say, okay, I'm not going to, so your cost. So your objective is to reduce the cost by as much as possible. You want to make 100% profit, you want, so, so what happened? You if you talk about, let's say, soap company, okay? If soap company, or let's say laptop company wants to make profit, so what they will do? They will hire big factory. They'll hire 1 lakh employees. They'll make 1 lakh laptops per day, right? They can make 1 billion profit every day. Is it possible? It is not possible, because there are a lot of constraints. You may not find 1 lakh people to work for you, maybe. Even if you hire and get it people from different states, different countries, okay, you may not have enough resources. You may not have enough hard disk, enough RAM, to make a desktop or laptop. Let's say you make those things also. Then you may not have enough demand, right? If demand is not unlimited, right? If I start a training institute, I can hire a big cinema hall and I say, okay, I will train 10,000 people at a time. Is it possible? No. You do not have demand for 10,000 people, right? So there are a lot of factors based on which a business depends. It depends upon the demand, it depends upon the supply, it depends upon the cost, okay? So there are a lot of factors on which business depends. So optimization is how to play with these, we call them as constraints. How to play with the constraints so that you get maximum profit or minimum cost, minimum expense. Okay, so your aim is to reduce the expense as much as possible. So you'll play with those factors to reduce the cost. You'll play with those factors to increase the profit. Okay, so there, okay, that is an extension of linear algebra. Okay, it's called optimization problem. Optimization problem is equally good or equally important like machine learning. Okay, so again, I think both of you must have done that in your graduation level. You have operations research. Operation research is the subject of optimization only. Both of you must have done, right? Operation research.
Yes.
Yes,
Right?
sir.
So OR, operation research OR is your optimization problem. Whether you're trying to increase the profit, reduce the cost, you're trying to find the lowest cost for your transportation problem, okay, or sequencing problem, right? So their objective is to minimize the cost or maximize. Two possibilities, right? Either to minimize or
Like
maximize.
by using graphical method, all those
Correct. You can do using graph theory or
simplex method.
right, simplex method. We will try to do using Python. We'll implement simplex method using Python. Okay, we'll look at the Python function which will execute. So it's a simplex only, but we will implement using Python. Okay, so for that we need what is called as SciPy. SciPy is the next level of NumPy, which stands for scientific Python. Okay, it stands for scientific Python. So all those complex problems, okay, like optimization, like your combination, permutation, combination, okay, all those things are possible using SciPy. Most of these scientific stuff are designed to work with, you can do integration, differentiation, all those things. Okay, if you have done physics or some of those signal processing kind of applications, okay, you can solve using SciPy. So we'll just see. Okay, mostly we'll use NumPy and pandas only for our analysis. Okay, but let's learn how to solve optimization problem. Okay, so you might have to solve optimization problem also at your work. So we'll take SciPy. SciPy, as I said, stands for Scientific Python. You'll have to import SciPy. Okay, so SciPy, and it has sub packages. Okay, so optimization problem. Let's look at how to solve. Okay, optimization problem, or we also call it as inequality problem. Okay, so here, okay, just give me a second. I'll open the book. Okay, I think Abhi, you have to collect the book. Okay, you don't have it, I guess. Data visualization. On that book, page number 79. Okay, you're going to work to solve page 79. So here the problem statement says that you are a company, Indigo Computers, and they make notebook and desktops. Okay, this is a problem from internet. Okay, which I have taken, very old problem. So you'll see in MBs, but of course our focus is to solve using Python. So ignore the problem as such. Okay, so SciPy, and the problem here is, so you are a Indigo Computers. Okay, best is to solve using Excel first. Okay, then tomorrow we'll solve using Python. So let me open an Excel. Can you see the Excel?
Yes, sir.
Yes, right. Okay. Okay, so here you have desktops. Here you have laptops. Okay, let's say desktop quantity is X and laptop quantity is Y. Okay, to find one feasible solution, we'll start with assuming that you make one desktop and one laptop. Okay, this is assumption. Okay, this is to find. Okay, okay, then we have to talk about constraints. Constraints. Okay, the first constraint it says is each computer requires one processing chip. One computer requires one processing chip. So if you have one desktop, that means you need one processing chip for desktop and one processing chip for laptop. Okay, and you have total only 10,000 available. Okay, so that means when you have only 10,000 available, can you make 20,000 laptops or 20,000 desktops? No, maximum itself is 10,000. So either you make 5,000, 5,000, 9,000, 1,000, right? You can't make 10,000, 1,000 or 5,000, 6,000 because this is 10,000. The limit itself is 10,000. So this is your first constraint. Second constraint, okay, we'll say here chip, processing chip. Okay, so you talk about processing chip. Then you have memory chip. So what I'll do, I'll move this here, and here we'll have the calculation. Okay, so that means if you make one desktop, so you need 1 into 1 plus 1 into 1 laptops. So 2 you need. and this 2 has to be less than 10,000, obviously. So when you talk about memory chip, it says each computer requires memory. Memory comes in 16 MB. A notebook has 16 MB and desktop needs 2 chipset, okay, 32 MB. So desktop needs 2 and laptops needs 1. So now, okay, I can fix D5 and E5. So I'll say function F4. Function F4 $sign will fix. So now when I'll do Control C and Control V. I'm copying and pasting, or you can drag also. So when you drag, what happens? Since D5 and E5 we have fixed, it remained D5, E5. But here D9, D8 and E8 I did not fix it. So when I move down, so I'm moving down. What is relative movement? I'm increasing the row by 1. So D8 and E8 became D9 and E9. Row I'm increasing, so row increase, but I'm not moving along x-axis. So I'm not changing the column. So column remains same, and this is what we want, right? We want D5 into D9 into your E9 into your E5. Okay, so this should be less than equal to what? It says total availability is 15,000 chipset. 15,000. Okay, there's one more construction called assembly time. Okay, you have limited machine, right? So machine can only work for 24 hours a day, right? So you cannot make machine deliver or work for 30 hours a day. Okay, maximum it can work is only 30 hours. It can work for less than 24 hours, but it can't work for more than 24 hours, isn't it? So it says notebook needs 4 minutes versus desktop for 3 minutes. So desktop needs only 3 minutes of assembly time and laptop needs 4 minutes. So again, I will go and drag it here. So 3 into 1 plus 4 into 1, 7. And this has to be less than equal to total assembly time available. That is, it says 25,000. 25,000. Okay, great. Now, your aim is to figure out these two values, correct? So that these constraints meet these constraints. And at the end of the day, what is your objective? Okay, I need to find number of desktop and number of laptops to find the maximum profit. Okay, objective is profit. And what does profit says? It says you are making, okay, it says, 750 profit on each desktop, no, on notebook, and 1,000 on desktop. So you're making 1,000 rupees profit on desktop and 750 on notebook. Okay, this is what it says. So total profit is going to be 1750 if you have 1. So our objective is to maximize this. What is the maximum profit based on given condition? So you click here and you go to data, and here you will have what if. Click on what if. Scenario manager goals data table. No. Is it in? Solver. We need solver. You don't see solver here, right? So let's go to this add-ins and see if you have solver. It's freely available, okay? So you go to here and options. Okay. In options, you go to add-ins. You can see my Excel screen, correct? Go to add-ins and you see solver add-in. Yes, no.
Yes.
Solver
Yes, sir.
add-in. and you say okay. Huh? Did I make any mistake? File, options, add-ins, solver add-in. Now let's say, okay, Excel add-in go. Yeah, so you'll see this. So these things are available for you, but these can take a lot of time. Okay, so this kind of slows your Excel. So by default, they are not they are not attached to your Excel. But if you need it, you can. Analysis tool pack we will use later when we do machine learning. For now, we need solver. So you say solver and you say okay. Okay, it'll take some time and see solver has appeared here under the data. So click on solver. If you click on solver, you will see an option here. It says set objective. Set objective is F12. So if you select and click here, automatically select. Otherwise, you can click on this option and select F12. Okay. So our objective is to find F12 or F12 here or profit. Should it be maximize, minimize, or exact value? You want exact value also, you can use it. Okay, I want exact profit of 10,000 rupees. Then how many laptop and how many desktop should I sell? Okay, here my objective is to find as high profit as possible. So you say objective. So set F12 to maximum. By changing cells, which cell you want to change? By changing these two cells, right? How many desktop can we make? These are the cells that you need to change. Okay, so by changing D5 and E5, great. Subjects to constraint. So you have to add all these constraints. So add. So this has to be less than. You can select less than, greater than, equal to, right? So less than 10,000. Okay, add. Next constraint, this should be less than this. Add. Third constraint is 7 has to be less than, okay, 25,000. Okay. So see, all three constraints are added. Okay. Now you say solve. Okay. So see, it has solved. So what it says is you need to make 7,000 desktop and 1,000 laptops. If you're happy, you say okay. Otherwise, if you say restore original values, it will redo. Okay. So I'm happy with the answer. I'll say okay. So see, Excel tells me that I need to make 7,000 desktops and 1,000 laptops. This is the best combination. Any combination other than this, one, it may not be possible. Second, okay, if it is possible, then it will not give me maximum benefit, maximum profit. Okay, if I try to make one extra laptop, you see here what happened? Assembly time is full and memory chip is full. Processing chip, you still have 200 with you, or 2,000 rather, 2,000 with you. But memory chip and assembly time is all consumed. So you cannot make even one more laptop or desktop. But you will say, okay, let me reduce one desktop and let me increase one laptop. You can try doing that, your profit will go down. So this is the maximum profit, the business can give it to you. Did you understand? Okay, so this is the maximum profit you can generate given these conditions. Okay, this is how you can solve optimization problem using Excel, and you can solve using graph. Okay, so you can refer how to solve using graph from the book. Tomorrow we will see how to do using SciPy. Make sense?
Yes, sir.
So we'll solve using SciPy and then we'll move to pandas. Pandas is important for us, so we will move to pandas after solving this.
Yes.